Welcome back to our channel C for Carbon. Our question here is the bond length of the molecule B2 is greater than F2, but still the bond dissociation enthalpy of B2 is greater than F2. Why? So in order to get clear answer to this question, we have to apply MO theory, that is molecular orbital theory, on both these molecules B2 and F2. First, we will apply this theory on MO theory on B2 molecule. Each boron atom contains 5 electrons. So, B2 molecule will totally contain 10 electrons, right? So, we are applying the MO theory on B2 first. So, if you apply the MO theory on B2, the electronic configuration will come as sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Next will come pi 2px1 is equal to pi 2py1. So total 2, 4, 6, 8, 9, 10 electrons are completed. Okay. Now we are applying this MO theory on F2. Each fluorine atom contains 9 electrons. So total of 18 electrons will there be in F2. So if you apply this MO theory on F2, you will get sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Now before pi 2px equal to pi 2py, you know what sigma 2pz will come. Take sigma 2pz2, then pi 2px is equal to pi 2py, both contain 2 electrons. Then pi star 2px is equal to pi star 2py, and both contain 2 electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18. 80 electrons are completed. So if you look at this MO order or the electron filling in MOs, in case of B2, the highest occupied molecular orbital, we call that as HOMO. Okay, in short, HOMO is a bonding molecular orbital or BMO. Okay, highest occupied molecular orbital in B2 molecule is a bonding molecular orbital, and in case of F2, the highest occupied molecular orbital or HOMO is an anti-bonding molecular orbital. We call it as, in short, ABMO. And there is a theory that there is a concept that if the electrons are filled in bonding molecular orbital, stability will increase, and if the electrons are filled in anti-bonding molecular orbital as in F2, stability will decrease. So in case of B2, since the HOMO is a BMO, stability of B2 molecule increases, and in case of F2, since the HOMO is an ABMO, that is anti-bonding molecular orbital, the stability of the molecule decreases. As a result, the bond energy of B2 becomes greater than F2, even though the bond length of B2 is greater than F2. Thank you. If you like the video, share the video and kindly subscribe to the channel.